Missile. A V-2 rocket launched by the British during Operation Backfire is shown in the picture. In modern language, a missile, also known as a guided missile, is a guided self-propelled system, as opposed to an unguided self-propelled munition referred to as a rocket. Although these two can also be guided, missiles have four system components: targeting or missile guidance, flight system, engine, and warhead. Missiles come in types adapted for different purposes: surface to surface and air to surface missiles, ballistic cruise, anti ship, anti tank, etc., surface to air missiles and anti ballistic, air to air missiles, and anti satellite weapons. All known existing missiles are designed to be propelled during powered flight by chemical reactions inside a rocket engine, jet engine, or other type of engine. Non-self-propelled airborne explosive devices are generally referred to as shells and usually have a shorter range than missiles. The picture shown is the HNLMS DZ-1 Provincian F-802 firing a harpoon. In ordinary British English usage, predating guided weapons, a missile is such as objects thrown at players by rowdy spectators at a sporting event. The picture is V1 missile. The first missiles to be used operationally were a series of missiles developed by Nazi Germany in World War II. Most famous of these are the V1 flying bomb and V2 rocket, both of which used a simple mechanical autopilot to keep the missile flying along a pre-chosen route. Less well known were a series of anti-shipping and anti-aircraft missiles, typically based on a simple radio control command guidance system directed by the operator. However, these early systems in World War II were only built in small numbers. Technology. Guided missiles have a number of different system components: targeting or missile guidance, flight system, engine, warhead. Guidance system. Missile maintainer inspects missile guidance system of the LGM-30G Minuteman ICBM. The most common method of guidance is to use some form of radiation such as infrared lasers or radio waves to guide the missiles onto its target. This radiation may emanate from the target, such as the heat of an engine or the radio waves from an enemy radar. It may be provided by the missile itself, such as a radar, or it may be provided by a friendly third party, such as the radar of the launch vehicle or platform, or a laser designator operated by friendly infantry. The first two are often known as fire and forget, as they need no further support or control from the launch vehicle or platform in order to function. Another method is to use a TV guidance with a visible light or infrared picture produced in order to see the target. The picture may be used either by a human operator who is steering the missile onto its target or by a computer doing much the same job. One of the more bizarre guidance methods instead used a PGN to steer a missile to its target. Some missiles also have a home on jam capability to guide itself to a radar emitting source. Many missiles use a combination of two or more of the methods to improve accuracy and the chances of a successful engagement. Targeting system. Another method is to target the missile by knowing the location of the target and using a guidance system such as INS-T or COM or satellite guidance. This guidance system guides the missile by knowing the missile's current position and the position of the target and then calculating a course between them. This job can also be performed somewhat crudely by a human operator who can see the target and missile and guide it using either cable or radio based remote control or by an automatic system that can simultaneously track the target and the missile. Furthermore, some missiles use initial targeting, sending them to a target area where they will switch to primary targeting using either radar or IR targeting to acquire the target. Flight system. Whether a guided missile uses a targeting system, a guidance system, or both, it needs a flight system. The flight system uses the data from the targeting or guidance system to maneuver the missile in flight, allowing it to counter inaccuracies in the missile or to follow a moving target. There are two main systems: vectored thrust for missiles that are powered throughout the guidance phase of their flight, and aerodynamic maneuvering wings, fins, canard aeronautics, etc. Engine. A simplified diagram of a solid fuel rocket. Number 1. A solid fuel oxidizer mixture. Propellant is packed into the rocket with a cylindrical hole in the middle, is shown in the picture. Number 2. An igniter combusts the surface of the propellant. Number 3. The cylindrical hole in the propellant acts as a combustion chamber. Number 4. The hot exhaust is choked at the throat, which among other things dictates the amount of thrust produced. Number 5. Exhaust exits the rocket. Missiles are powered by an engine, generally either a type of rocket engine or jet engine. Rockets are generally of the solid propellant type for ease of maintenance and fast deployment, although some larger ballistic missiles use liquid propellant rockets. Jet engines are generally used in cruise missiles, most commonly of the turbojet type. Due to its relative simplicity and low frontal area, turbofans and ramjets are the only other common forms of jet engine propulsion. Although any type of engine could theoretically be used, long-range missiles may have multiple engine stages, particularly in those launched from the surface. These stages may also be of similar types or may include a mix of engine types. For example, surface-launched cruise missiles often have a rocket booster for launching and a jet engine for sustained flight. Some missiles may have additional propulsion from another source at launch. For example, the V-1 was launched by a catapult, and the MGM-51 Shellak was fired out of a tank gun using a smaller charge than would be used for a shell. Warhead missiles generally have one or more explosive warheads, although other weapon types may also be used. The warheads of a missile provides its primary destructive power. Many missiles have extensive secondary destructive power due to the high kinetic energy of the weapon and unburned fuel that may be on board. Warheads are most commonly of the high explosive type, often employing shaped charges to exploit the accuracy of a guided weapon to destroy hardened targets. Other warhead types include submunitions, incendiaries, nuclear weapons, chemical, biological, or radiological weapons, or kinetic energy penetrators. Warheadless missiles are often used for testing and training purposes. Classification of missiles. The missile is only guided during the relatively brief initial powered phase of flight, and its course is subsequently governed by the laws of orbital mechanics and ballistics. Attending at the target, missiles can be classified as anti-submarines, anti-aircraft, anti-missile, anti-tank, anti-radar, etc. If we look at the military function, missiles can be classified as strategic and tactical. However, the most extended criteria is as follows: air-to-air launched from an airplane against an aerial target. Surface to air, designed as defense against enemy airplanes or missiles. Air to surface, dropped from airplanes. Surface to surface, supports infantry and surface operations. Warheads are most commonly of the high explosive type, often employing shaped charges to exploit the accuracy of a guided weapon to destroy hardened targets. Other warhead types include submunitions, incendiaries, nuclear weapons, chemical, biological, or radiological weapons, or kinetic energy penetrators. Warheadless missiles are often used for testing and training purposes. Classification of missiles. The missile is only guided during the relatively brief initial powered phase of flight, and its course is subsequently governed by the laws of orbital mechanics and ballistics. Attending at the target, missiles can be classified as anti-submarines, anti-aircraft, anti-missile, anti-tank, anti-radar, etc. If we look at the military function, missiles can be classified as strategic and tactical. However, the most extended criteria is as follows: air-to-air launched from an airplane against an aerial target. Surface to air, designed as defense against enemy airplanes or missiles. Air to surface, dropped from airplanes. Surface to surface, supports infantry and surface operations. Air to surface, dropped from airplanes. Surface to surface, supports infantry in surface operations. Ballistic. The picture is an R-36 ballistic missile launched at a Soviet silo. After the boost stage, ballistic missiles follow a trajectory mainly determined by ballistics. The guidance is for relatively small deviations from that. Ballistic missiles are largely used for large attack missions. Although normally associated with nuclear weapons, some conventionally armed ballistic missiles are in service, such as MGM 140 ATACMS. The V2 had demonstrated that a ballistic missile could deliver a warhead to a target city with no possibility of interception, and the introduction of nuclear weapons meant it could efficiently do damage when it arrived. The accuracy of these systems was fairly poor, but post-war development by most military forces improved the basic inertial navigation system concept to the point where it could be used as the guidance system on intercontinental ballistic missiles flying thousands of kilometers. Today, the ballistic missile represents the only strategic deterrent in most military forces. However, some ballistic missiles was being adapted for conventional roles such as Russian Iskander or the Chinese DF-21D anti-ship ballistic missile. Ballistic missiles are primarily surface launched from mobile launchers, silo ships or submarines, with air launch being theoretically possible with weapons such as cancelled Skybolt missile. The Russian Topol SS-27 CKB is the fastest 7,320 meters per second missile, miles per second missile currently in service. Cruise missile. The picture shown is the United States Tomahawk cruise missile. The another picture is Indian supersonic cruise missile BrahMos. The V1 had been successfully intercepted during World War II, but this did not make the cruise missile concept entirely useless. After the war, the US deployed a small number of nuclear armed cruise missiles in Germany, but these were considered to be of limited usefulness. Continued research into much longer range and faster versions led to the US SM-64 Navajo and its Soviet counterparts. Buria and Buran cruise missile, however, these were rendered largely obsolete by the ICBM and none were used operationally. Shorter range developments have become widely used as highly accurate attack systems such as the US Tomahawk missile and Russian Kh-55. Cruise missiles are generally further divided into subsonic or supersonic weapons. Supersonic weapons such as BrahMos are difficult to shoot down, whereas subsonic weapons tend to be much lighter and cheaper, allowing more to be fired. Cruise missiles are generally associated with land attack operations, but also have an important role as anti-shipping weapons. They are primarily launched from air, sea, or submarine platforms in both roles, although land-based launches also exist. Anti-ship. The French Exocet missile in flight is shown in picture. Another major German missile development project was the anti-shipping class such as the Fritz X and Hensel HS-293, intended to stop any attempt at a cross-channel invasion. However, the British were able to render their system useless by jamming their radios and missiles with where wire guidance were not ready by D-Day. After the war, the anti-shipping class slowly developed and became a major class in 1960s with the introduction of the low-flying jet or rocket-powered cruise missiles known as sea skimmers. This became famous during the Falklands War when an Argentine Exocet missile sank a Royal Navy destroyer. A number of anti-submarine missiles also exist. These generally use the missile in order to deliver another weapon system such as a torpedo or depth change to the location of the submarine, at which point the other weapon will conduct the underwater phase of the mission. Anti-tank. US Army soldiers firing an FGM 148 Javelin is shown in the picture. By the end of the World War II, all forces had widely introduced unguided rockets using high explosive anti-tank warheads as their major anti-tank weapon. However, this had a limited useful range of 100 meters or so, and the Germans were looking to extend with the use of a missile using wire guidance, the X-7. After the war, this became a major design class in the later 1950s, and by the 1960s had developed into practically the only non-tank anti-tank system in general use. During the 1973 Yom Kippur War between Israel and Egypt, the 9M14 Malyutka Sacker man-portable anti-tank missile proved potent against Israeli tanks. While other guidance systems have been tried, the basic reliability of wire guidance means this will remain the primary means of controlling anti-tank missiles in the near future. Anti-tank missiles may be launched from aircraft vehicles or by ground troops in the case of smaller weapons. Anti-ballistic. The picture shown is Aero Missile. Like most missiles, the S-300, S-400 missile, advanced air defense, and MIM-104 Patriot are for defense against short-range missiles and carry explosive warheads. However, in the case of a large closing speed, a projectile without explosives is used. Just a collision is sufficient to destroy the target. See Missile Defense Agency for the following systems being developed. Aero 3 Kinetic Energy Interceptor, Aegis Ballistic Missile Defense System, Aegis PMD, and SM-3 missile with a lightweight exo-atmospheric projectile leap kinetic warhead KW. Air-to-air. The picture shown is AF-22 Raptor fires an AIM-120 AM RAM. Soviet RS-82 rockets were successfully tested in combat at the Battle of the Khalkhin Gol in 1939. German experience in World War II demonstrated that destroying a large aircraft was quite difficult, and they had invested considerable effort into air-to-air missile systems to do this. Their Messerschmitt Me-262 jets often carried R-4M rockets. Other types of bomber destroyer aircraft had unguided rockets as well. In the post-war period, the R-4M served as the pattern for a number of similar systems used by almost all interceptor aircraft during the 1940s and 1950s. Most rockets, except for the AIR Air-2 Jenny, due to its nuclear Soviet RS-82 rockets were successfully tested in combat at the Battle of Khalkhin Gol in 1939. German experience in World War II demonstrated that destroying a large aircraft was quite difficult, and they had invested considerable effort into air-to-air missile systems to do this. Their Messerschmitt Me-262 jets often carried R-4M rockets, and other types of bomber destroyer aircraft had unguided rockets as well. In the post-war period, the R-4M served as the pattern for a number of similar systems used by almost all interceptor aircraft during the 1940s and 1950s. Most rockets, except for the AR-2 Jenny, due to its nuclear warhead with a large blast radius, had to be carefully aimed at relatively close range to hit the target successfully. The United States Navy and US Air Force began deploying guided missiles in the early 1950s, most famous being the US Navy's AIM-9 Sidewinder and USAF's AIM-4 Falcon. These systems have continued to advance, and modern warfare consists almost entirely of missile firing. In the Falklands War, less powerful British Harriers were able to defeat faster Argentinian opponents using AIM-9L missiles provided by the United States as the conflict began. The latest heat-seeking designs can lock onto a target from various angles, not just from behind, where the heat signature from the engines is strongest. Other types rely on radar guidance, either on board or painted by the launching aircraft. Air-to-air missiles also have a wide range of sizes, ranging from helicopter launch self-defense weapons with a range of a few kilometers to long-range weapons designed for interceptor aircraft such as the R-37 missile. Anti-satellite. The picture is ASM-135 SAT missile launched in 1985. In the 1950s and 1960s, Soviet designers started work on an anti-satellite weapon called the Istrevital Sputnik, which literally means interceptor of satellites or destroyer of satellites. After a lengthy development process of roughly 20 years, it was finally decided that testing of the Istrevital Sputnik be cancelled. This was when the United States started testing their own systems. The brilliant Pebbles defense system proposed during the 1980s would have used kinetic energy collisions without explosives. Anti-satellite weapons may be launched either by an aircraft or a surface platform depending on the design. To date, only a few known tests have occurred.